Hello, everyone. Welcome to our second week. So last week we have covered some introduction, very basic introduction to regression, including some of the terminologies, like what is explanatory variable and what's the response variable, and how what's the basic flow to create our linear regression model. And also we discussed how do we do the estimation by a least square method in both of the math calculus format and also the matrix format. Okay, for this week, we will do a bit of example by running our code to show you how are we really going to do the regression model and plot our data, etc. So here, this slide is just to show you the very basic syntax that we are going to use to build the linear model. And I'm going to show you how do we actually run it from our session. Okay, I hope you guys can see my screen, which is our interface. Actually, it's our studio interface. Oh, by the way, I have posted a section on our Blackboard called R, which covers how do you download R and how do you download R Studio, and it has step-by-step instruction how you can do it. I hope you have some time this week to get it all installed and also try this code, which I also posted online. Okay, let's start from here, reading the data from a .csv file. And also I posted this .csv file to our Blackboard as well. So let's run it from the very beginning. So on a Mac, you can do command and return, or you can do whoops. Sorry, I should have said it's command plus enter. Sorry about that. So that's how I run this line, and you see this variable, this data set appear in my environment already. Right, this is some basic outline of the data. If you want to take a look at the data, it's just like this. It has quite some information, but we're just going to use this Obama 12 and Obama 08 as the percentage that Walter have for different states. Okay, so this is how do we get the data into R. And of course, you have to change this directory here, which give you the location of this .csv file. And I also give you an example of how do you read it in a Windows setting, where it's a little bit different from Mac, if I remember it correctly. Like you have to specify the detailed location as well, but you use this instead of this to get to the location. And also on Windows, you do Control plus R to run the syntax. Or there's another way, like if we just select the whole line, well, actually you do not need to select. Just put your cursor there and you do command and return, like on my computer is command return. Then you run this line, and you can also like highlight to run, like highlight the whole thing to run it. So anyway, well, another little trick. If you find this is a little bit messy and you want to get rid of it, I think you can just Control L you get rid of it already. Well, the second, once I get the data into my R session, I want to do a scatter plot. Remember that every time when we do a regression, the best way is to plot your data first. So here is how I plotted. I put the explanatory variable, our x, in front, and then it's the response variable, the y, in the second. And this is x label and y label, which is the label for the x-axis and y-axis on your plot. Let's take a look. Okay, now you see I run this line and the plot just appeared here. And I have the label here and the label there for X and Y. And this is our data. So it looks like the trend on the plot is just a linear line, right? So then we can do a linear model on it. So when we do this linear model, we do, this is y tilde x. So it's a bit different from when you do the plot, right? Okay, let's run this line. See, I put my cursor here and I just decline and return, I can still run it. Now we have our model, like my.lm. This is what it looks like. It's a little bit messy here, but the best way to see the result is to run a summary of your model. Let's do it here. Okay, so this tells you what is the command that you do the model, like what the model looks like, and this is some summary statistics for the residuals, and more importantly, it's the coefficients section. This section, oops, where it shows you the estimate and standard, the estimate for intercept and for the slope. This is for the slope of our x. This is our x variable, explanatory variable, and the standard error for those estimates, and also a t-value, a p-value. We will use this again over and over again in today's session. Just pay attention that this is how we get it. We get it from our model to a summary, and this is just one section of the summary. Okay, now we got our estimate. I'd like to plot this estimated regression line to our scatter plot. How are we going to do that? Just do this AB line, run it, see it just appear on the scatter plot, right? It looks like it fit the data pretty well, right? Okay. Well, the second part we'll talk about that later, but here I just want to show you how did I actually read my data in R and how to plot a scatter plot and do a linear model, eventually get our summary and visualize the regression line. How does it fit to the data from the plot? Okay, well, I have some outline of the syntax that I used, but if you want to get more information about the syntax, a good way to get help on R is you do this question mark and then the command. Okay, let me just show you, like if you do this, question mark LM, then it will give you to this help page, and then you can read like what is each of the syntax the argument represents. Sometimes it's a little bit too detailed. The best way to use this help, at least for me, is to get to the bottom by this examples, or sometimes run the examples or just read the syntax in the example would help you a lot. Okay, so this is the about the R code to get the estimates. Okay, yeah, in this page we I'm just I'm just telling you how do we extract this coefficients from our R results. I showed you this is the intercept and this is the slope for the x. So put in the our formula, y equals to this intercept plus slope times x. So how are we going to interpret the slope in context? So remember, we are fitting this percentage of people voted for Obama in 2008. We use this one to predict, to fit for the percentage of voter for Obama in 2012. So if we put it in context, that is, if the percentage of the voters voting for Obama in 2008 increased by 1 percentage point, then the percentage in 2012 increased by approximate 1.056 percentage point. That is, if our x increased by 1 unit, and then the y, our response will increase by approximately this amount. Okay, this is the interpretation. And for different contexts, you of course would have a little bit of different, but the logic flow is like this.